ib3 higher level students, today I'm going to solve REST exercises from our November 2019 session. I'm not going to give you full solutions, but I hope you did this. If not, you can check. I'm talking about method how to solve it. Okay, first exercise, you have a classical singly anionized helium atom with single electron orbiting. Okay, what is important here, a little bit different than usually. Electron is single, so has a charge of 1. In the nucleus we have 2 protons, so charge of the nucleus is 2. Okay, and you have to prove that speed is given by this expression in the first exercise, and that total energy of electron is given by this expression in second exercise. Okay, so first with speed. It's easy. Electric force is equal to centripetal force, so K, Q, so 2Q times Q, so Q over R squared is equal mv squared over R. Finally, speed is given by this. Okay? Total energy. Total energy is sum of kinetic and potential. Okay, kinetic is half of mv squared, where v is given, so 2ke squared over mr, plus potential, which is negative and equal q times charge over r. So finally you can cross m, you can cross 2, and you have ka squared over r, and here we have minus 2k. Q is the same as e, so e squared over r, so finally is minus ke squared over r. Okay, so next exercise. In this model, the electron loses energy by emitting electromagnetic waves. Describe the predicted effect of the emission on the orbital radius. Okay, so again, let's focus on this part, on this total energy. Okay, so when electron loses energy, then left hand goes down, so right hand also goes down, but right hand is negative. This is negative sign, which means that ke squared over r must increase, so denominator r must decrease. So the result is that the radius decreases. You must show it by something I did. Okay, and the Bohr model of hydrogen can apply to single ionized helium atom. In this model, the radius r is given by 2.7 times 10 to the power of minus 11 times n squared, where n is a positive integer. So let me change the screen. Okay, so we know that r is given 2.7 times 10 to the power of minus 11 times n squared. Okay, and you have to show that the Broglie wavelength at n state is given by lambda equals 5.1 times 10 to the power of minus 10, so n is equal to 3, and the formula for the Broglie wavelength is lambda equals h over m times v. So all you have to do here is to calculate speed at third orbit. So here you have to use this expression. Okay, this expression. So first, you know general formula for n, r, and you know that n is equal to 3. So you have to find r3, which is 2.7 times 10 to the power of minus 11 times 3 to the power of 2. Then, by using charge of electron, Coulomb's constant, and mass of electron, you can calculate speed of electron at third orbit by 2 times k from data booklet times e squared from data booklet divided m from data booklet, and r3 is calculated here. Okay? Now if speed is given, then you can find here. If speed is given, then you can find the Broglie wavelength by expression, this one, h over m times v. Of course, for n equals to 3, we have v3. Okay? So next, estimate for n equals to 3 ratio between circumference and de Broglie wavelength. So circumference of the orbit is of course 2 pi r divided by wavelength. R was calculated, lambda was calculated, the result should be 3. Okay? And next, description of the electron is different in Schrödinger theory and the Bohr model. Compare and contrast description of the electron according to the Bohr model and the Schrödinger theory. So the best is to use fact that in the Bohr model, electron can be localized. Electron has a mass and speed and occupies a certain orbit. In the Schrödinger model, electron is represented by wave function, so we cannot find a certain position. The position of the electron is described with probability. And the same with speed. So in the Bohr we have certain position, in Schrödinger probability. In the Bohr we have a certain speed, in the Schrödinger we have speed which is given with probability. Is that clear? Okay. So exercise number 9, capacitors. Okay, we have X of capacitance of 18 microfarads and which has a charge of 48 microcoulombs. So let me change the screen. Okay, so X has a capacitance 18 microfarads and it stores charge of 48 microcoulombs. Okay, and there is a switch, and calculate the energy stored in X when the switch is open. So energy is half of Q times V, where the link between Q and V and C is given by C over V. So by using second equation you can calculate V because C and Q are given. Substitute here and find energy. This is total energy of the system. Okay, second, capacitance of Y is 12 microfarads, so Cy is 12 microfarads, and calculate the final charge on X and the final charge on Y. So we know that total charge is 48 microcoulombs because this is charge at the beginning when switch is open. So we know now when switch is closed that Qx plus Qy is equal to 48 microcoulombs, a law of conservation of charge, and we know that potential difference must be the same. So Q across X divided by C over X must be equal to Q across Y over C across Y. And by using these two equations where C of X and C of Y are given, you can calculate Qx and Qy. Okay? Calculate the final total energy stored in X and Y. So final energy stored is energy on X plus energy on Y, where energy of X is half of, we know Q and we know C. So the best is to write Q squared over C, of course in the case of X, and of Y, Qy over C in the case of Y, and you have to add both. Okay, and probably this energy will be less than initial energy. Suggest why answer A and B are different. So, in my opinion, answer at A is bigger than answer at B. Why? Because we have resistor. To charge a capacitor Y, current must flow, so heat is dissipated in the resistor. So answer is because thermal energy is created when current flows. Okay, exercise number 10, your favorite topic, yes? We have lens which is coated with thin film of magnesium of thickness D. The wavelength is given 636 nanometers. The angle of incidence is theta. Two reflected rays are shown. We know some data and predict whether a reflected ray undergoes a phase change. So remember, phase changes only if wave is reflected by denser medium. So all you have to do here is to check is medium denser or not. So let's look. They're asking about reflected X. So X is this. The point of reflection is here. Here is X. This is the point of reflection. So air has refractive index of 1, magnesium fluoride has a refractive index of 1.38. What does it mean? It means that wave is reflected by denser medium, so the phase changes by pi. B. Thickness of the magnesium is d, and for normal incidence we have to find in terms of d the path difference between the reflected ray x and y. Okay, the path difference, the real path difference is of course 2d, because the second travels distance longer by this, and of course now the question is asking about path difference in nanometers or path difference including the phase difference. In my opinion is 2d, but of course it can be shifted also by half of the lambda. In next is calculate the smallest value that will result in destructive interference between x and y. Okay, so let's look. In this part you have to express this path difference, yes, by this path difference is influenced by three things: by change in phase, by real path difference, and by reduction of wavelength in the film. So you can write something like this: 2d multiplied by 1.38, because you have to increase the wavelength by 1.38, because if it enters in magnesium fluoride, then it's reduced by 1.38. Okay, and we know that this is shifted by half of lambda because we have change in phase in this point, and again half of lambda because we have also change in phase in this point. The refractive index of lens is 1.58, so double change of phase results in no change in phase. And this must be equal to condition for destructive interference. So destructive interference is if path difference is equal n plus half of lambda, and minimum thickness, so for n equals to 0. So finally you have d is equal to lambda, which is given, divided by 2 times 1.38. Is it clear? Okay, discuss practical advantage of this arrangement. Practical advantage of this arrangement is the fact that we can reduce the glare, we can reduce the reflected ray of the lens. So finally we can reduce the glare which occurs when light illuminates the surface. Okay, light from a point source is incident on the pupil. The diameter of the pupil is 2.8 Joule, axis variation with diffraction angle of intensity of light incident on the retina. Okay, this is typical diffraction pattern, so nothing special. Okay, so let me copy this picture. Okay, nothing special, typical diffraction pattern, so you have to plot something like this. Okay, estimating radius, the smallest angular separation of two distant point sources of light of wavelength 656 nanometers that can be resolved by the eye of the observer. Okay, resolved means that the angle of observation must be equal to Rayleigh criterion, so 1.22 lambda over b is the angle, lambda is given, b is diameter of the pupil, which is also given, and this angle must be equal to the trigonometrical angle, which means what is the, they are asking about angular separation, so you don't need to calculate distance, and this is the answer. So angle must be equal to Rayleigh criterion, so 1.22 lambda over b. Okay, exercise number 11, we have monochromatic light of very low intensity is incident on the metal surface. The light causes the emission of electrons almost instantaneously. Explain how this observation does not support the wave nature of light and does support the photon nature of light. So let's focus on the first, does not support the wave nature of light. Okay, so let's imagine, oh wait, I have to copy this. And new page. Okay, so let's look. Let's imagine that you have light of very, very small intensity. What does it mean? That photons of, let's say, small energy travels one by one. If this photons hits electron, then electron should accumulate energy. Let's imagine that you have electron which needs, let's say, 100 units of energy. If each photon has 2, then for waiting, if you will wait a certain time for 50 photons, then energy should be enough to emit electron, but with delay. Okay, so if intensity of light is very, very small, in light nature, in wave nature of light, the electron still can be emitted with delay, but this is not observed. Okay, what with this? If photon has a particular frequency bigger than threshold frequency, then electron absorbing this photon is emitted instantaneously. Okay, so again the question was electrons almost instantaneously, means that each single photon has enough energy. If this photon is absorbed, then electron is emitted instantaneously. In the case of light, in small intensity, we have to wait, which is not true. Okay, and last, we have experiment. We have a wavelength of 480 nanometers, metal surface. The graph shows the variation of the current in diameter and the potential due to the cathode. Calculated the work function of the metal surface. Okay, so by using this graph, we can reach stopping potential, which is around minus 1.5 volts. So I'm going to use this minus 1.5 volts. So we can calculate energy of kinetic energy of electron Q times V, which is 1.5 electron volts, and using equation that frequency times Planck's constant is equal work function plus kinetic energy, of course converting it into joules. Frequency is given not directly because we have wavelength, so frequency can be found by using wavelength over speed of light. C is F times lambda, so F is C over lambda. Lambda is given, you can calculate F. H is a constant, kinetic energy is here, but you have to convert it into joules. So finally you have work function. And there's one more, I see? Yes, it is. The intensity of light is incident on the surface is reduced by half without changing the wavelength, drawn the graph variation of current with the potential difference. So intensity is less. What does it mean? It means that we have less photons, so less electrons emitted, but each electron has the same energy. So you have to start here because the same stopping potential, the same energy, but current is less because we have less electrons. Okay, so thank you for watching. Comment this movie. If you have any questions, ask me. See you next time. Bye.